Now we will find equivalent focal length of two thin lenses kept in contact with each other. Suppose there is a lens 1 that is denoted with the letter L, capital 1, L1. There is an object which is kept left hand side of the lens L1. Incident ray coming from the object and incident on the surface left hand side of the lens L1. Bending action due to the concept of refraction takes place, and that is emergent ray 1 coming to the point B on the principal axis, forming image I1. So for the image I1 formed by the first lens L1, we get 1 divided by V1 minus 1 divided by U, which is equal to 1 divided by F1, that is focal length. Suppose this is equation 1. Now another lens L2 is kept in the path of emergent ray 1. Then another ray, that is the emergent ray 2, come into the existence and forming image I. So for lens L1, image formation I1 takes place, and for this image I1 there is an object O. But for the image I1 is a virtual object due to this lens L2. Formation of I takes place. For the image I formed by the second lens L2, we get 1 divided by V minus 1 divided by V1 is equal to 1 divided by F2. Suppose this is equation 2. On adding equations 1 and 2, we get 1 divided by V minus 1 divided by U, which is equal to 1 divided by F1 plus 1 divided by F2, and this is suppose equation 3. Since they are acting like single lens, we are considering combining effect resultant of both the lenses L1 and L2. So focal length 1 upon F is equal to 1 divided by V minus 1 divided by U, which is equal to 1 divided by F1 plus 1 divided by F2. This is suppose equation 4. So focal length of both the lenses when they are kept in contact with each other, that is the equivalent focal lengths of two thin lenses, is given as F is equal to focal length of lens 1 and focal length of F2. So product of these two divided by summation of both the focal lengths for the lens 1 and focal length for the lens F2. So finally F is equal to F1 multiplied by F2 divided by F1 plus F2. So this F is equivalent focal length. It is just like a single lens. Now we will see equivalent focal length of the two thin lenses separated by certain distance, suppose D. Equivalent focal length of two thin lenses separated by distance. So there is a deviation of light ray by thin lens takes place. So this delta is a deviation forming image at point this on the principal axis at a focal length F. So tan delta, which is equal to delta is equal to H divided by F. Suppose there is an object kept left hand side of the lens, this to the L. So OL is U. As per sign convention, it is minus U, and this Li is V. So deviation produced due to this lens into the incident ray is given as angle AOL. This O is the object plus L plus angle AIL. This is the image which is equal to H divided by minus U plus H divided by plus V, which is equal to H into bracket 1 divided by V minus 1 divided by U. Delta is equal to H divided by F. Since 1 upon V minus 1 upon U is equal to 1 divided by F. Light travels in a rarer medium, then there is no bending action takes place. Unless there is a obstruction in the path of the light ray, like a denser medium. For example, lens into the path of light ray, which is traveling in a straight manner. When light ray travels in a rarer medium, it follows straight path. As soon as there is a lens which is kept into the path of light ray, which is traveling in a straight manner, bending action takes place due to the concept of refraction. Deviation by thin lens takes place. This is the incident ray, this is the lens. So deviation delta 1 takes place. So incident ray further becomes emergent ray, suppose 1. Forming image at this point on the principal axis at the focal length f1. So delta 1, that is the deviation produced by the light ray due to emergent ray due to this lens, delta 1 is equal to h1 divided by f1. Now another lens L2 is kept in the path of emergent ray 1. Then emergent ray 2 come into the existence and forming image R. Image formed due to the lens L1 was I1 at a focal length f1. Both the lenses are separated with a certain distance d. Focal length due to the L1 and L2, that is lens 1 and lens 2, is this f. Deviation delta 1 produced due to lens L1 by the concept of refraction gives us h1 divided by f1. Now, when we are considering delta, that is the deviation produced by the second lens L2, which is coming into the path of emergent ray 1 and forming emergent ray this 2. Yeah, this is emergent ray 2, making certain angle, that is the delta 2. If we are extending further in this manner, so there is one angle, that is the angle delta, and that angle delta is equal to h1 divided by f. Now another angle, another deviation takes place due to the second lens L2, which is this delta 2, and that delta 2 is equal to h2 divided by f. This is the focal length f2 for this image I. For this image I1, there is an object left hand side of this lens L1. But for the image I1 is a virtual object, and this image I form here at a focal length of f. Now delta is equal to delta 1 plus delta 2. Here delta is equal to h1 divided by f. This h1 divided by this f is equal to h1 divided by f1, that is delta 1. And delta 2 is equal to h2 divided by f2. Further, from triangle AC1, f1 and triangle BC2, f1, we have H1 divided by H2 is equal to F1 divided by F1 minus D. That is, H2 divided by H1 is equal to F1 minus D divided by F1. So from this, H2 is equal to H1 into bracket F1 minus D divided by F1. So value of this H2 to be kept here in this equation. Further, H2 is equal to H1 into bracket F1 minus D divided by F1. Put this value in this equation H2. So therefore H1 divided by F is equal to H1 divided by F1 plus H2 divided by F2 gives us H1 divided by F, which is equal to H1 divided by F1 plus H1 into bracket this term. H1 into bracket F1 minus D, this F1, this F1, this F2, this F2. So F1 into F2 takes place. Now H1 divided by F is equal to H1 divided by F1 plus H1 into bracket F1 minus D divided by F1 into F2 further gives us 1 divided by F is equal to 1 divided by F1 plus into bracket F1 minus D divided by F1 into F2. H1 get cancelled. That is why we are getting this equation. Now 1 divided by F is equal to 1 divided by F1 plus F1 divided by F1 into F2. We are separating these two terms, F1 and D, plus minus D into bracket minus D divided by F1 into F2. So further we will get 1 divided by F is equal to 1 divided by F1 plus this F1 get cancelled. That is why 1 divided by F2 minus D divided by F1 into F2.